If you like this channel, please subscribe. Thank you.
So the third class of receptors, and this is again part of the membrane, are called receptor kinases. Here's the membrane. Here's the extracellular side. Here's the cytoplasm. So you want to think of the receptor as a multifunctional protein. You don't need to know the details, but here's an example really of the receptor enzyme is the insulin receptor, and it's depicted this way. Here, 2 alpha subunits, 2 beta that span the membrane, and they're exposed on the cytoplasmic side. So this entire thing is the receptor. You don't need to know the details, and remember, these are proteins. Basic stuff I repeat because people forget, okay? These are polypeptides. They're protein in nature. So here's insulin. It's going to bind to its receptor, activate the receptor. When it activates the receptor, it activates an intrinsic kinase activity. And that kinase activity, you all remember what kinases do. They add a phosphate, typically, to a protein or an enzyme at hydroxyl residues, most likely. In this case, this kinase is specific for tyrosines. So when you activate the insulin receptor, you activate the tyrosine kinase activity of that receptor. I want you to appreciate that in that beta subunit shown here, this is again a polypeptide. There are several tyrosine residues, part of that polypeptide. They get phosphorylated by the intrinsic kinase activity of the receptor. That's called autophosphorylation, meaning the receptor phosphorylates its own subunits on specific tyrosine residues. These aren't loose tyrosines. They're part of the receptor itself, of the polypeptide making up the beta subunits. Very important. So that is a sign that the receptor has been activated by activating the tyrosine kinase activity. The tyrosine kinase then can phosphorylate other intracellular proteins on tyrosine residues, changing their activity. Some enzymes may be activating, inhibiting, some changing the way they associate with other proteins, and so on. But the key thing is you activate once the insulin binds to its receptor. The first thing that gets activated is the intrinsic tyrosine kinase activity of the receptor. Okay? And this is actually something that we're going to talk about a lot, the insulin and its receptor and how it affects many pathways. So you really want to know that. So this is a third class of receptors, that the receptor itself is an enzyme. That enzyme doesn't get activated until the hormone binds to it. The specific activity of that enzyme is tyrosine kinase, meaning it will phosphorylate specific tyrosine residues on itself and on other cellular proteins. Okay, so that's the third type of receptor.
If you like this channel, please subscribe. Thank you.